Question number 17. Hamming codes are used for option A, burst error correction, option B, single error correction, option C, both A and B, option D, none of the above. So let us see this question. This question is very simple and straightforward. You need to remember only one point regarding the Hamming codes, then you can answer this question. The point is, Hamming codes can be used to correct at most maximum of 1 bit error data. If you are transmitting, say if you are transmitting a password of 100 to your friend, and she has received, unfortunately he or she has received unfortunately at 101, then only 1 bit error it has occurred. So 1 bit errors you can correct using Hamming code. Suppose she has received as 001, then first bit is error and the last bit is error. So Hamming codes cannot be used at this point. So I hope you understood in which cases Hamming codes can be used to correct the data. That is only 1 bit error. If it contains only 1 bit error, if the data is only 1 bit, you can use Hamming codes. So I think option B is right choice. Single error correction is possible. But option C says it can be both A and B. So let us see what is this burst error correction. Before we proceed to burst error corrections, let us see what are burst errors. So for this, I have taken an example by which you can easily understand. Assume that this is the transmitted symbol or password which you have sent to your friend, and assume that this is the received code word. First bit, it is error free. Second bit, it contains an error, just highlight. Third bit, error free. Fourth bit, error free. Fifth bit, error free. Sixth bit, it again contains a error bit. Seventh bit is error free. You can see there are 2 bits which are error prone. So what is this burst errors? I'll give you a brief definition of this. Burst error should satisfy 3 conditions. That is, the start bit should be an error bit, and an end bit should be an error bit. I'll tell you what is the start and end bit. And the middle bits, they can be error prone, or they can be error free also, means no error bits. So what I'm saying is, I can call this total is an error block. I can call this completely as error block. This error block is called burst. Okay, so you might be awaked that even though this middle bits doesn't contain any error, but still I can call this as a burst. Burst means the start bit should contain an error, and an end bit should contain an error, and middle bits, it may contain error or it may not contain error, it doesn't matter for me. So I hope by this definition, start bit should be an error, end bit should be an error, and middle bits, it should be an error, or it should not, error may not contain in this middle bits. So that is the definition of burst error. Now you might have understood that a burst means it doesn't involve any single bits. Single bits are not possible because it should contain at least one start bit, end bit, and middle bits. So burst is nothing but group of bits. Burst means group, bulk. Some people will call it as bulk errors also. So group of bits having error. So our Hamming codes, I already told you, it can correct only 1 bit data which contains error, whereas this burst or bulk, it itself indicates, I have told you a definition, it has bulk of errors. It has bulk of errors, means more than one. So this cannot be the right choice. Therefore C cannot be the right choice. So the right choice is option B. Now let us see the extension of this Hamming codes or Hamming distance, so related to this, so that it is very useful in your competitive exams. Based on this concept, a question was asked in GATE 2017 recently, CS set 2, I guess. Yeah, CS set 2. For CSE, it was there in networking, computer networking. For us, it is there in communication. Both are interlinked when you go to your higher studies. Fine. Now let us see the extension of this. Let me read you the statement, then I'll explain you what is involved in it. If D minimum d min is the minimum Hamming distance. So I'm telling you something new concept known as Hamming distance. Hamming distance. So I'm denoting Hamming distance with d min, minimum Hamming distance, hence I denoted with d min. If d min is the minimum Hamming distance, then maximum number of erroneous bits that can be detected. So if I say d min is 5, then how many errors I can detect and how many I can correct? That's a question. Suppose if d min is 5, then you can detect maximum errors. Maximum you can detect 4 errors. If it is 5, it is 4. Minimum will 4 bits of errors you can detect. And how many you can correct is 5 minus 1 by 2. So it is nothing but 2 bits you can correct. Maximum 2 bits. Maximum. Remember the word maximum. Maximum you can detect and correct, and distance is minimum distance. Try to remember this. I'll give an example in detail. What is Hamming distance? You will understand. Hamming distance. For this, consider 3 code words which was received here. Okay, this is the first code word, this is the second code word, third code word. Okay, so these are the received bits. Assume received code words or passwords or whatever you say. Okay, so first one is this. Let us compare the difference between first bit and first password and second password. So this and same. Here there is a change. I am indicating a change with an arrow, two-sided arrow, bidirectional. Here it is same. Here again it's a change. Here again it's a change. So how many times the bits have changed? That is known as Hamming distance. That is denoted with the letter D. Hamming distance is very simple. It's nothing but difference in the change of the character between one code word to other code word. Here it is 3. Let us compare between second code word and third code word. Here it's a change. Here it's a change. Here it's a change. So many changes you can see. Here it's a change. Here no change. Okay. Here also no change. No change. Now what is the Hamming distance between these two? It was this. Between these two it is 4. Now you can compare between 1 and 3 also. So let me compare 1 and 3. So 0 and 1, there is one Hamming distance. I'm noting here. I'm comparing between this and this. Okay, so 0 and 1, this and this, there is a Hamming. Okay, I'll indicate with some other color. Okay, so this and this, there is a one Hamming distance. 0 0, no Hamming distance. 0 1, one Hamming distance, I mean one bit change. So 0 0, no change. 0 1, one bit change. So between this and this, the Hamming distance is 3. So out of this 3, which is minimum, that you need to choose. So D minimum is 3. Now maximum number of bits it can detect and correct using this Hamming distance, I'll tell you. How many bits it can detect is, I have given you a formula. This is directly asked in CS question and many times in AC also. So number of bits it can detect is D min minus 1. This yields to 3 minus 1, 2. Next, it can correct, number of bits it can correct is D min minus 1 by 2. So it is nothing but 3 minus 1 by 2. This yields to 1. 1 bit it can correct. This 2 bit it can detect, 1 bit it can correct. Try to remember these two formulas, very important, and also try to know how to calculate the Hamming distance. Okay, so this extension is very important. Please note it down. Thank you.